Welcome. Our goal in this video is to get some application with the distance formula. Now in these examples we're going to look specifically at when they give us points to work with and they want us to find the distance between those 2 points. So let's get started right away. What if they give us a point, I don't know, 3, 1 right here, right, 3, 1, and they say, well, the other point is 5, 4. Okay, so notice the first thing I did, right? They might just list these points, 3, 1 and 5, 4. One thing I might do right away is to graph those points because that tells me that the distance between them is about this distance right here, this line that I'm drawing. So that's the distance, right? And as we find it, we should keep in mind how we're actually going to do that, and we should think about, well, to get that distance, it's approximately, right, 1, 2, 3, at least 3 away from the other point. That gives us a sense of just how far these two things are. Now the distance formula, as we talked about in other videos, right, distance is just equal to the square root of the difference of the x values, right, and we can write that as a shorthand, delta x, or triangle x, squared, right, plus the difference of the y values squared. Or we could reverse that. There's no need to write one before the other. We're just adding. So it's delta y squared, right, plus delta x squared. Either way we do it, as long as we're adding correctly in the end. So the distance between these 2 points would be what? Well, I'm going to use this formula right here, right? Subtract the y values first. So I'm going to choose this point as the starting points. So 1 minus 4, so the square root of 1 minus 4 squared plus, well, 3 minus 5 squared. So we add these up, and d is going to equal what? Well, 1 minus 4 is negative 3. That squared is 9. Plus 3 minus 5 squared is 4, because 3 minus 5 is negative 2. Squared is 4. And d, right, is equal to the square root of 13. And what's that between? Well, it's between 3 and 4, right? Because 3 squared is 9 and 4 squared is 16. So this distance right here is equal to the square root of 13. You can approximate that more in your calculator if you'd like, using the square root function. And as a reminder, all we're doing here, when we find the delta y values, it just says, well, how far is this distance right here? How far is the height difference between those 2 points? Well, we subtract, and we did 1, right, minus 4 squared, because when you're squaring this as well, you're applying the Pythagorean theorem, but you can subtract either way, right? Either way you get 3 or negative 3, depending on that order, but this height distance right here is 3, and then when we subtract the x values, we're looking at these points right here. So we subtract the 2 x coordinates as well. And that gives us that right triangle. You can see it right there. So we're really just solving for the hypotenuse in the distance formula. Let's try another one. What if there's some negative values in there? How does that affect stuff? We'll look at that example. Let's pick negative 2, 3. Let's try this point. Negative 2 and 3. And then let's try negative 4 and then up to 5. So negative 4. And then 5. So now we're trying to find this line right here, right? And as we find our delta x and our delta y, we're forming that right triangle. So in this case, what will the distance equal? Well, let's reverse it this time. Let's use this formula. We subtract our 2 x values. I'm going to use this value right here. So 5, oops, that's our y value. Oh boy, sorry. Negative 4 minus negative 2. And what's that? Well, negative 4 minus negative 2 is really negative 4 plus 2, which is negative 2, and we're going to square that. Plus, well, same order, 5 minus 3, and that's 2 squared. So now d is equal to negative 2 squared plus 2 squared, and what is that? Well, negative 2 squared is 4, plus 2 squared is 4. This is the square root of 8. And you can break that up a little bit. D is equal to 2 times the square root, right? Because because this is equal to 2 times 4, and the square root of 4 is 2. So 2 times the square root of 2. And every square root of 2 is about 1.4, right? 1.41 or whatever. And we're doubling that, so it's a little bit under 3, right? Because the square root of 8 is between 2 and 3. But anyway, the point is here that whether you have a negative or a positive, you can apply a distance formula simply by picking one of the points as your starting values. In this case, I chose this point. And then I did -4 minus -2, right? And then I do 5 minus 3. So I'm just sure to keep that order in. If I pick this point first, I subtracted these point values, the x from this x value and this y from that y value. I'm just very careful about the order. That's the only thing that can really throw me off. Now there are two other sets or types of points they can give you. Like they might give you -3, right, and 2, 3. So these 2 points. So before you go and plug the formula in for this one, which we can do in a moment, let's just look at this one. Don't forget to use your intuition. Here you can just see the distance between these 2 points. It's from -3, right, on the x, all the way up to 2. And that's a distance of 5. So in this case, our distance equals 5. But we can still apply the distance formula. In this case, distance equals what? Well, this time, right, if we subtract our x values, we get -3 minus 2, which is what? Well, that's -5, right? -3 minus 2 is -5. We're going to square that, and then add -3 minus -3. Well, -3 minus -3 squared, right? That's our formula there. We square the delta y and delta x, or differences in x and y. That's equal to -3 plus 3, which is just what? Well, -3 plus 3 is 0, and 0 squared is 0. So this is 0. And d ends up equaling this. Well, -5 squared is 25, right? And the square root of 25 is equal to 5, which is our distance right here. Same is true with a vertical line. If they give you a vertical line, just count the distance between, right, before you even attempt to apply the formula, because you can just count. Like these 2 points right here are just 1, 2, 3, 4, 5 away as well, vertically. But if you use the distance formula now, think about this one. When you subtract the x values, that'll equal 0, but the y values are different, right? The heights are different, but the x values are both on this line. Either way, you'll still get the correct answer, whether the x's or y's are subtracting out to 0. Right? The distance formula will work with any type of line, even a less friendly one. Let's look at another one. Okay, so what if they give you something, and this is the same idea, it just looks a little bit less friendly, with a bunch of radical signs. So what if they said, find the distance between the following? What if they gave you the square root of, I don't know, 5, and then comma, and they mix it up a little bit. Maybe they do -2 times the square root of 3. And then they say between this point and this point right here, 2 times the square root of 5, and then, I don't know, square root of 3. Well, how would you do this? Well, the distance formula, again, can be applied, because d just equals the square root of all this stuff squared, essentially. Let's look at the x values first. We have square root of 5 and 2 times the square root of 5. Well, we're going to subtract. And because this is a higher number than this, right here, right, 2 square roots of 5 is more than 1 square root of 5, I want to keep things positive. So I'm going to start with this value, 2 square root of 5, and subtract this value, which is less from it, to keep it all positive. Although it doesn't really matter because we're squaring anyway, it's just easier for me. Then we're going to add, I got to start here again because I started with this point, the square root of 3, right, minus -2 square root of 3, and that's going to be squared as well. Okay, so now what? Well, 2 square roots of 5 minus 1 square root of 5 is just the square root of 5. It's square root of 5 squared. We'll get back to that in a second. So we have all this, the square root of 5 squared, plus this thing in here. So we're going to expand this a little bit by saying, well, square root of 3 minus negative square root of 3 is square root of 3 plus, right? Because we're subtracting a negative, so you add 2 square roots of 3. That means we have 3 square roots of 3 squared. And we're getting somewhere now. So what's the square root of 5 squared? Well, think for a moment if you took, here's a little side note, if we took the square root of 4, which is 2, and then we took 2 and we squared it, we would get 4. So if I did the square root of 4 squared, that's what this process would be saying right here. Take the square root of 4, which is 2, and then square it. Whenever this happens, whenever you take the square root of some variable and you square it, you just get the variable itself. So square root of x squared is just x. And that has a lot to do with the fact that the square root and exponent undo each other. The same thing's happening here. Square root of 5 squared is just 5. Let me change colors there. It's just 5, and then the square root of this squared, well, plus, this is going to square the 3 to 9, and the square root of 3 to just 3. So now we get 5 plus 27, or 32. And now what we have is that this is equal to the square root of 32. That's the distance. You could approximate that on a calculator. It's between two numbers, right? It's between 5 and 6. Closer to 6 than 5, but it's a decimal between there. So you can work with radicals as well on the distance formula. Alright, thanks a lot.